Hi everyone, welcome back. Today we're going to be working on 9.7, which is going to be volumes of prisms and pyramids. So let's get right into this. We talked about prisms already. We basically know that a prism is a three-dimensional or 3D solid with, let me zoom in here, two congruent bases and lateral sides connecting them. We also know that the bases have to be polygons, meaning figures that don't have any curved edges and that are complete all the way around. So here we have a couple examples. We have a triangular prism here, a rectangular prism, and a pentagonal prism, right? So the volumes of prisms is pretty simple. It's just the area of the base times the height. You can see that the B in base for the formula, is a capital B. Now this might sound a little bit hypocritical of me considering I write in all caps all the time, but it's important that you use a capital B in this case because capital B represents the area of the base shape, okay? Not just the length or anything else like that. It's the area of the whole base. So for an example, if we wanted to calculate the area of the triangular prism, we would have to find the area of this triangle, which just happens to be the same as this one. It doesn't matter which one you use because by definition, a prism has two congruent bases, right? So you find the area of one of the bases and just multiply it by the height, which is right here. So that's pretty much it. So we need to understand our area formulas for things like triangles and rectangles and so on. And a lot of the times we're going to be using Pythagorean theorems and trigonometry to help us solve these types of problems, right? So let's get right into it here with exercise number 1. It says a prism has a base that is an equilateral triangle whose sides measure 6 inches each. The height of the prism is 8 inches. What is the volume of the prism to the nearest cubic inch? All right, so we have a height of 8 inches, so all of these are 8, right? That's always consistent all the way around. We also have the base is an equilateral triangle with 6s. Now, it's not really necessary for me to write all these numbers in because it does kind of look confusing, but you can if you want to. What I am going to do, though, is I'm going to redraw one of the bases flat, right, because it is an equilateral triangle, and we're going to figure out how to find the area of that triangle. So we know that this is 6, 6, and 6. Now, if we find the area of this equilateral triangle, we can just multiply it by 8, which is your height, and we're going to find our volume. Simple as that. But finding the area of this triangle is a little bit tricky. Okay? You have to realize that an equilateral triangle can be cut into two congruent right triangles, right? And those right triangles are going to be congruent because we know that an altitude is also a median, is also an angle bisector, is also a perpendicular bisector in an equilateral triangle. So we know these two pieces are the same, the angles are the same, and everything else. All right, so we know that the two triangles are congruent. So we know that this piece here is going to be 3, and this piece here is going to be 3, as the whole thing is 6, right? So what we can do is we can focus on just one of these triangles and find the area of it and just double it, okay? So we need the height and the base of the triangle, right? Because the area of a triangle is 1/2 height, or base times height, right? Height times base times height, same thing. So the height and the base must be perpendicular of one another. So the 3 and the 6 are not perpendicular to each other. That's not true. So we can't use the 3 and the 6 as the height. We need to use the 3 and what I'm going to label the x. All right? The 3 and the x are perpendicular to each other based on the definition of an altitude. So I need to find out what x is. And the way that I'm going to do that is I'm going to use Pythagorean theorem. A squared plus b squared equals c squared. All right? Remember the hypotenuse is always opposite the right angle, which is 6. We'll do 3 squared here, and we'll call this x squared here. So we have 9, 36, x squared. So what we're going to do is we're going to subtract 9 from both sides. and we get x squared is equal to 27, which we'll take the square root of and eliminate or reject the negative value that we get and only keep a positive one because we can't have a negative length. So x is equal to the square root of 27. All right, so we know the height of the triangle now. Now, if we're just trying to find the area of the red triangle, that's going to be equal to 1/2 3 times rad 27, right? But we need two of those. We need two of those triangles because we have this one here and we have this one here. So what we're going to do is just multiply this whole thing by 2. And if you think about it, the 2 and the 1/2 simply kind of just cancel out, essentially. So what we end up with is the area of the whole triangle, the black triangle, all the way around, is going to be equal to just 3 rad 27. Simple as that. All right? Now, that is a big part of this question, and you would definitely get partial credit for getting that far, but we want to find the volume. So the volume of this whole thing is the area of the base, which is that 3 rad 27 times the height. So we have 3 rad 27, and we're going to multiply it by 8. And if you remember anything about multiplying radicals, you know that you treat the number outside the radical like a coefficient. So when you multiply 3 rad 27 by 8, you just multiply the 3 and the 8 to get 24 on the outside and leave the radical on the inside. Now, we're technically almost there. We're not fully there yet because the question asks, what's the volume to the nearest cubic inch? Which means I'm going to have to put 24 rad 27 in my calculator, and that'll spit out approximately 125 inches cubed. And that right there is going to be your final answer. All right? So, a decent amount of work, so it's not as simple as it seems, but the process isn't bad really at all. You just find the area of the base, multiply it by the height, and you're done. Just make sure you follow exactly how they ask you to do it, whether it's in cubic inches or leave it as a radical form, or round to a decimal, or whatever it may be. All right, let's take a look at number 2. So this one is definitely going to involve some trigonometry here. We have a non-right prism, meaning it's not standing perfectly straight up and down. It's kind of slanted. It has square bases. Okay. 2 vertical faces that are rectangles. Okay. And 2 vertical faces that are non-rectangular parallelograms. The side view of the non-rectangular parallelogram is shown. So I'm pretty sure this piece right here is this piece right here. So the prism technically is, this is going to be our base, okay? Even though it's like, it doesn't seem like the base traditionally, this is the base we're going to use because we know that this side is the same as this side over here. And we have information about the base, so that's why we're choosing to make that the base. All right. So we know this is 7, this is 4, and this is a 58-degree angle. So we need to determine the volume of the prism to the nearest cubic inch. So, does it give us the height? Ah, I know why. Okay, so these guys here, let me get a different color. These sides are squares, so that green and that green, those are squares. Which means if this is 4, this must also be 4. Okay? So, actually, no. What the heck did I just say? Sorry, 7. I don't know what I'm doing. So, remember, if this is 7, then all of these must be 7. So, all the green lines are 7. 7, 7, all the way around. Why is that important? Because 7 is going to be the height. Okay? So, we know that the height is equal to 7. The height of the prism is 7. So, here we go. We need to find the area of this guy now. That's our main priority. Then we just multiply it by 7, and we're done. So I'm going to go ahead and do my best to redraw this diagram over here. Why don't I show you this little trick? You circle that, you duplicate it, you bring this guy, lock it in up there, bring this guy, and lock it in here. There you go. Now you have a perfect little parallelogram. And we know this is 7, we know this is 58, and we know that this is 4. So we have a base. We need a height. all right? Because the area of a parallelogram, or area of any four-sided figure, is just going to be the base times the height. But remember, the base and the height have to be perpendicular. So what we're going to do is we're going to draw in a dotted line representing an altitude. And we need to find what this altitude is so we can multiply it by 4 to get the area. Now, let's zoom in on this. Essentially what we're going to do is we're going to use this right triangle to find x. We can't use Pythagorean theorem because this whole amount represents 4. All right? We can't use 4 as this value here. It doesn't work like that. So we're going to have to use trigonometry, SOHCAHTOA. All right? So we have, from our angle measure, we have an opposite and a hypotenuse, which tells me I'm going to use sine. So I'm going to do the sine of my angle measure, 58, is equal to the opposite, which is x, over 7. So if you remember how to do this, you put this over 1, you cross multiply, and we get 7 sine 58 is equal to x. Now, if you plug that in your calculator, you get x is, now we want to write the entire value down. We don't want to round until the very end. Very important. 6.950108537. All right? So that is the height of this thing. Now we're going to take that and multiply it by 4. Why are we multiplying it by 4? Because here is my height that we just found, and here's the base. Those are the ones that are perpendicular, the 4, right? So we're going to take this, we're going to multiply it by 4, and we get 27.800434415. Okay? So now what we are going to do, this is the area of the base, right? So what we need to do now is take that area of the base, and we just need to multiply it by 7. So give me a second here. I got to put in the calculator, 27.08843415 times 7. And does it say to round? Yes, round to the nearest cubic inch. So we end up with, so we did the area of the base times 7, and we ended up with about 195 inches squared. All right? And that'll be the volume for that prism. All right? So let's continue on here. We are now going to move on to pyramids. So we're going to talk a little bit about pyramids. Pyramid is almost like a prism, but it's pointy. So it has one base, and the vertical lines that go up, instead of meeting an identical base at the top, they come to a point, kind of like in this problem here. So you can see that if you had a prism, right, and then you fit it inside of, if you had a pyramid, this guy right here, and you fit it inside of this prism, right, there's a lot of empty space left inside of the prism, right, that's not taken up by the pyramid, okay? Now, basically what we can do is we can figure out the ratio of empty space to what's actually the pyramid, and that's how we come up with our formula. And it's very simply that the pyramid, this guy here, takes up 1/3 of all of the space in this prism that matches its base, okay? So it's only 1/3 of the total volume of that prism. And that's exactly what this formula is telling us. So the volume of any pyramid is just 1/3 the volume of what the actual prism would have been, right? If it didn't come to a point on the top, right? So like if I decided to take these up like this and make a prism out of this, I don't know why my hands are so shaky. But if we do go ahead and do something like that, we know that the area of this pyramid is 1/3 the volume of that pyramid is 1/3 the volume of the whole prism. So anyway, that's where the formula comes from. Let's jump right into it now. So again, big B means area of the base. So in question number 3, it says, this is a real life problem, okay? These are real measurements. So it's kind of interesting. The Great Pyramid of Giza in Egypt has a square base that measures 756 feet on a side and has a height of 481 feet tall. To the nearest million cubic feet, what is the volume of the Great Pyramid? So this one doesn't seem that difficult. Let's just go ahead and calculate the area of the base. So the area of the base, well, the base is just a square, so it's going to be 756 times 756, right? So for that one, that should give us 571,536. So that is how many square feet the area of the base is. Now we need to take that number and multiply it by the height, which is 481. So we're going to take 571,536 and multiply it by 481. And we have to remember, when we're doing the volume of the pyramid, it's equal to 1/3 of this value when you multiply them together, right? A lot of people forget to do that. Don't forget about the 1/3 part. So you go ahead and do this, and you end up with 916366272, which reads, I believe, 91,636,272. So we want to round, and this is feet cubed, right? We want to round to the nearest million. So the millionth place is right here. I'm going to look at the 6. The 6 is telling me that I should round up. So that's approximately 92 million cubic feet. All right? So that's it for that question, right? Not too bad. You could have also put 92 million like that as well. Okay? All right, let's move right along here. It says, find the volume of the square pyramid. So again, we have a square pyramid. This one is called an oblique pyramid because it is slanted, all right? It's not perfectly straight up and down like the nice pyramids in Egypt, right? It's a weird looking one. And we need to find the volume of it. We know that the base is a square, so everything's going to be 20, right? 20 times 20. And let's go ahead and find the area of the base. So we have the area of the base. It's just a square. That's this guy down here, right? So it's just 20 times 20, which is 400. Okay? So that's 400 inches squared. Now, to find the volume of the pyramid, we need to do 1/3 the area of the base times the height. And we just want to make sure it does tell us that the base is perpendicular to the height, which is good. That's very, very important. All right, it didn't tell us up here, but I believe it told us the height right here, which indicates that it's a right angle. Right. Anyway, so we're going to go ahead and do that. So we have 10 times 400 is 4,000, and then we have to take 4,000 and times it by 1/3 or divide by 3. Okay. Hold on, let me do that really quick. So 4,000 divided by 3. All right, so we end up with, and it doesn't tell me to round, so I'm not going to round. The volume of the pyramid is equal to 1,333.3 bar notation inches cubed. All right? So pretty simple, not overly complicated. All right. We are going to move on, do 2 more practice questions, and then you have a couple that you can try on your own. So let's take a look at number 5. It says find the volume of the cube. This is going back to just regular prisms, okay? Volume of a cube, well, I don't know why it says cube and gives you these dimensions. It's clearly not a cube. It's a rectangular prism. If it was a cube, everything would be the same, all the numbers. Anyway, I don't know why that said that. So we're going to find the volume of this thing. So the area of the base would be 8 times 15, and then we just multiply it by 10. Or you can just multiply all 3 of them together. because that's special about a rectangular prism. You can just do length times width times height. So we're going to do 8 times 10 times 15. All right, so our total volume is going to be 80 times 15, which comes out to 1,200. So 1,200 centimeters cubed. All right, so a pretty simple one. Just revisiting that so that we can come back and try number 6, which is a little bit interesting here. All right, let's take a look at this one. It says, a pyramid is constructed from a cube as shown below. All right, so the shaded area is the prism, or sorry, is the pyramid from the rectangular cube, right? So we have point C is the midpoint of the edge. Okay, so C is the midpoint, so we know that AC is congruent to CB. The cube has a volume of 216, so the volume of the cube is equal to 216. Now, a cube has all 3 dimensions the same. So what I can do with this is I can take the cubed root of 216. Now the way you do that is you go into math, and then you hit 4, and then you type in your 216. Basically, it's going to find a number that when multiplied by itself 3 times gives you 216. So that comes out to 6. So I know this cube is 6 by 6 by 6. All right, so I found that by working backwards with the volume formula. So I know those dimensions now, and that helps because I now know that this guy is 3. All right, this is 6 back here as well, this dotted line here. And what we're going to do is we're going to find the the area of this little triangle in here, because that's the base of this pyramid. And then we're just going to multiply it by 6, which is the height of the pyramid. So I'm going to redraw that little triangle out here, so it's a little bit easier to see. All right, so we have a 3, we have a 6 here, and we need to find this diagonal. Actually, do we need to find the diagonal? No, I don't even think we need to find the diagonal. So we have the 3 and the 6, which is good to go, right? So all we need to do is, here I have a base and here I have a height. They're perpendicular, right? Area of a triangle equals 1/2 base times height, and the base and the height have to be perpendicular. So the area of this triangle is going to be 1/2 6 times 3. So the area of the triangle is going to be 9. All right, not bad. So we just take 9 and we multiply it by our height, which is 6. And we also need to multiply it by 1/3. Don't forget about that. Remember, this is the volume now, volume of the pyramid. So we do 1/3, 9 times 6, and we end up with 18 centimeters cubed. All right? So we're going to do one more. I lied. I thought we only had up to 6, but we have 7 I forgot about. And then I'll let you guys work on these. Okay. So number 7 says, the rectangular pyramid has a square base. Oh, regular pyramid. I was going to say that's a little weird that it's saying rectangular, but okay, so we have a square base. So I'm going to use my my little method here of making a perfect little square base there. And it's got 4 lateral sides that are isosceles triangles, which makes sense. Actually, let's make this a little bit more like this, so I can see that side here, and there we go. So the lateral sides, or the lateral means like up and down, like a ladder, right? So this would be a lateral side, right? There's 4 lateral sides in here, and they're all isosceles triangles, right? Which means the base angles are the same, and these lines, these guys here, are also the same. So the length of an edge of the base is 10. So we have 10 centimeters. It's a square, so we know that all of them are 10 centimeters. And the height of the pyramid is 12. Okay, so this is actually a lot easier than I thought it was going to be. It gives us the height and an easy way to find the area of the base right away. So the area of the base, or area of the square on the bottom, is going to be 10 times 10, which is 100. And then we do the volume of the pyramid is equal to 1/3 the area of the base times the height. So if you want to figure out how to do this in your head really quick, I do 1/3 of 12 first. 1/3 of 12 is 4. 4 times 100 is 400. Right? So pretty straightforward. Volume is 400 centimeters cubed. Okay? So that's pretty much it for this. I want you guys to try those on your own. And if you have any questions, let me know. All right? Have a good day, guys.